Hello students, it's Ms. Kruger and I'm going to do a lesson with you on writing and solving equations through Edmentum. Let me go ahead and share my screen. Here we are. I'm on my whiteboard now, so be patient with me. Edmentum real equations, some materials you might want to have handy are your composition book and a pencil. The 610A learning target, which is an essential standard, is that you can model and solve a one variable, one step equation in inequality. Accelerated also did, I can model and solve one variable, two step equations in inequalities. Inequalities will not be included in the lesson. Also in the lesson is I can write an equation from a real world problem. When we're doing this, we look for what is unknown, we define the variable, and we write equation. Let me travel back over here. So some important vocabulary I wanted to review before we get started is that our coefficients are always located in front of our variables and our constants stand alone. Some things you want to remember: constants occur once in a problem and coefficients are reoccurring. So constants lend themselves to addition or subtraction, whereas a coefficient represents a multiplicative operation. Here is a problem that is already done for you in case you want to refer back to it. Fundamentals of writing equations from words. To write an equation with a variable, when you are given a description in words, you must identify the variable, the numbers, and the operations that the words refer to. So those are our basics. They have your variable, your number, and your operation. So our example, after Luis deposits 30 into his account balance is 72. We can write an equation from this word statement. Luis deposited, which is adding money to his original account balance to get the current balance. So the original balance plus 30 equals 72. We don't know the original balance in Luis's account, so if we use the variable x to represent the original balance, we get the equation x plus 30 equals 72. So then, once we write an equation, we can determine what was the amount in his account before the deposit. 30 equals 72. Line down the equal sign, you see it's addition, so we solve with subtraction. X equals 42. Luis had $42 in his account prior to adding 30. Number one, join me with the pencil if you can beat me to it. Awesome. Jessica is biking to her friend's house, which is 12 miles away. After she covers X miles, Jessica looks at her GPS and notices she is 4 miles away. Write an equation that will help you determine the value of X, the miles covered. So you might be thinking, oh, that's easy. Well, 12 minus 4 is 6. But remember, 12 minus 4 is not an equation either. So we have to write an equation. 12 being our total distance. She has covered X amount of miles and still has 4 to go. This is an equation, and now we can solve it. Minus 4, x equals 8. We know that this 4 is a constant. And she covered 8 miles and still has 4 to go. Here's another example. Jackie is at Chili's and she is buying appetizers for herself and her friends. She buys 4 appetizers for $24. Write this statement as an equation with a variable. The unknown quantity is the price per appetizer. So let's start writing our equation. You might be thinking, it's easy, Ms. Kruger, 24 divided by 4 would give us the price of an appetizer. And that's wonderful, but that's not an equation. So let's write an actual equation. 24 in our total, and then 4 times the price of an appetizer. This is written as multiplication, so we solve with division. Does division look like a fraction? So the price for 1 appetizer would be 6. Okay, let's go over here to Number 2, join me with a pencil. If you can beat me to it, awesome. There are 84 Skittles in a packet. Each of the 6 students received an equal number of Skittles. Write an equation that gives you S, the number of Skittles received by each child. Equal amount lends itself to 6 being a coefficient. We have our 84 Skittles, and each student is going to get an equal amount of Skittles. What do we see? Multiplication. How do we solve? Division. The amount of Skittles each child will get. 84 divided by 6 is 14. Each kid gets 14. Number 3, join me with a pencil. If you can beat me to it, awesome. Bradley runs 200 meters in 32 seconds. What is the equation for D, the distance in meters that Bradley covers per second? Distance per second is determining rate, and what do we know about rate? Rate numbers are always coefficients. So we know the total distance is 200, and he has a rate of 32. And we're going to use, not an S. So if we want to find the unit rate, the distance he can cover per second, then we are going to divide 200 divided by 32. Distance equals 6 and 25 hundredths of a meter per second. Four, arachnid spider collection has a total of 48 legs. If each spider has 8 legs, write an equation to represent how many spiders that arachnid has. So again, I know what your brain automatically thinks. You go straight to solving. But remember, we're going to write an equation first. So if we know we solve division, then that means we write with multiplication. 8 representing our total and 8 representing our coefficient. Now we have to be careful here because the mistake could be, well, what variable do I use, L or S? What are you looking for? Are you looking for legs or are you looking for spiders? So in this case, we are looking for how many spiders does arachnid have. So we want to use the variable S, not L. We're not looking for legs. We already know we have 48 legs. So we see multiplication. We solve with division. Division looks like a fraction. The amount of spiders that she has is 6. Jacob's mom bakes a cheesecake and divides it into 10 pieces. After serving 4 pieces to Jacob and his friends, she has P pieces left. Write an equation for P. So again, our brains go straight to, I know how to solve this. 10 minus 4, 6. So that's not an equation though. So we have to write with the inverse, which would be an addition problem here. So we have the pieces plus 4 total up to 10. We see addition, then we can solve with subtraction, which is where you were originally thinking of how to solve P equals. I know it's so easy to jump to, how do I solve this? But remember, sometimes your goal is to write the equation, and solving is secondary on some of the problems. It is being very sensitive. Very sensitive. There we go. Wow. Sorry, kids. It's a digital whiteboard, so this can be a little bit interesting at times. Okay, so let's do another one together. After adding 12 to a number x, we get 26. Write an equation to represent the situation above. This one is pretty straightforward. We have 12. We're adding 12 to x, and we know that is 26. 12 is your constant. We see addition, solve with subtraction, x equals 14. 12 is a constant. Next one over, Natalia has 54 songs downloaded on her iPod. This is 7 less than A, the number of songs Ashley has. Write an equation to represent this situation. So again, we're not looking for Natalia, we're looking for an equation that will tell us how many songs Ashley has. So we know how many Natalia has, and we know that this is 7 less than Ashley. So whatever Ashley has minus 7 gave us the 54 Natalia has. Again, what operation do we see? Subtraction. How do we solve addition? Ashley has 61 songs. 7 is a constant. Number 8, a writer can type at a rate of W words per minute. The writer typed 210 words in 3 minutes. Write an equation to find the rate of words W per minute. What do we know about rate? We know that rate is always a coefficient. So let's set it up. 210 is total. 3 is our coefficient, and we're looking for the number of words that can be typed in 1 minute, which is unit rate. So what operation do we see? Multiplication. How do we solve division? The words that can be typed per minute are 7. The unit rate of this is 70 words per minute. Number 9, on average, a Girl Scout can sell 126 boxes of cookies in 14 days. She can sell B boxes in 1 day. Write an equation that can be used to find the value of B. How many boxes does she sell per day? Again, this is a unit rate situation. So anytime you are looking for one, you're looking for unit rate. What do we know about rate? That is a multiplicative setup. So 126 boxes total, and she sold 14 over the course. She sold 126 boxes over 14 days. So we want to know the boxes that she sold per day. Rate is always a coefficient. Makes your number a coefficient. 126 divided by 14 is 9. 9 boxes per day. Let me see, I believe that may have been my last problem. We have gone through several together. Again, notice our goal was to write an equation, and we know that after we can write them, that we know how to solve them. Let me go back to my screen. If you need any additional help with writing or solving equations, please reach out to me and I'd love to help you. Okay, I will see you at our Zoom meeting later on in the week. Bye, guys.